My name is David Hayes, and this is C programming. And first thing we'll do is go over the syllabus, and then we'll go over some PowerPoint information, get into the software, and actually write programs tonight. So I'm not real big on when I got programming involved. I'd rather write programs and just cover 100% definitions. To get into Blackboard, you have to take an orientation. So if it's your first time in Blackboard, it'll force you to do an orientation before you can see your classes. Once you finish the orientation, then you should see a C programming option. And both of them should be the same. There's a start here. That's where your syllabus is located. And I got it in Word format and put it in PDF. The big goal is for it to be ADA compliant. And I like the fact it says perfect when it's in Word. When I put it in a PDF, it really bombs. So if you don't have Word then or some kind of editor to view it, then let me know and I'll send you the PDF. I uploaded some PDFs for the assembly language class, and they were failing miserably. They're like 10 or 15% ADA compliant. So I may put those in Word. As we're going through material, if you have questions, be sure to ask. You know, if you're at home or library or whatever, press your space bar and ask questions at any point. I like questions. If you don't understand something, I want to know that. My phone number's there. I'm almost, I am 100% certain that if you leave me a message, I actually get it now. For a longest time, my little voicemail light wouldn't light up when people left me a message. So I wouldn't get the message till like weeks later, months later. But since they moved me to the Sumner Center here in Wellington, it's worked 100% of the time, as far as I know. I haven't went out and found any messages out there that where the light wasn't flashing. Blackboard messaging is the best way to get hold of me for the class. Haven't come up with my office hours yet, but I'll post that after I come up with it. But even if my hours don't match yours on office hours, if you need a little help, let me know. I can get on Zoom at any point in time, and you can show me your screen. I can see what you're doing. We can work very collaboratively, even probably better than me watching over your shoulder. This course is offered to teach programming skills in C to students. Basic constructs learned in this course will apply to any programming language, slight modifications. C is kind of the holy grail for a lot of different languages. They're C-based. For example, Java is based upon C, C# is based upon C, C++ is somewhat based on C, so there's a lot of C-based languages. Upon completion of this course, students should be able to write programs using the C programming language. Students should be able to use input, output statements, selection statements, repetition structures, procedures, and arrays. Student will learn how to incorporate exception handling of the programs. Lastly, they'll know how to write and retrieve data from various sources. And just so I can get everybody written down. Oh, JC. Okay. Now, this right here, of course, is Cali. If I go to academics, maybe, did I click it? Probably didn't click it. Come down here to the natural science and math. There's a engineering pre. And this is where the Wichita State University 2+2 pathways is located. So if you haven't looked at that, if you're planning on Wichita State, C programming is used in other engineering programs and computer science. So if you're going computer science, but if I come down here, for example, and I look at electrical engineering, you'll see in this, C programming is right here. We've always offered C for as long as I can remember. Wichita State met with us a year and a half ago, maybe two, I think about a year and a half ago. And they said people coming to Wichita State didn't have the necessary background they needed to be as successful. They're coming to Wichita State. They should have been at a junior level, and they were back more at a freshman level, maybe a junior level, or maybe a sophomore level. They said they didn't have the basic fundamental classes they needed. So they met with us. They told us what we needed to add to our program. Now, they didn't sit and meet with us. They met with a lot of people. They sat down with Hutch. They sat down with Butler. They sat down with everybody because they were realizing people coming to Wichita State did not have those core classes they had to have, because these core classes are prereqs for all these other classes. And so if you don't have those core classes, then you have to take those before you can even take those junior level classes. So it really extended people's degree pursuit. Ones they told us, like I say, C programming was always there. I don't know if the introduction to engineering was there, and I'm not sure about that. That's not one we specifically talked about in the meeting. Engineering economy. That was a new one that they said we needed to add in. And that's offered at the Mulvane Center in the fall semester. Introduction to digital design. That's a real core one that was kind of a prereq for about everything else. And that's offered in the fall semester. That's I teach it here, but I also broadcast it out over the internet. So if you're in Arc City, if you're in Mulvane, wherever you're at Blackwell, wherever you're located at, you could watch the lecture from home. The Engineering Probability and Statistics 1, that's offered at Mulvane. Humphrey Wamoka teaches that. And if you're going to engineering, your elementary statistics is not acceptable. They want a calculus-based statistics class, and that's what this one's focused on. The I thought there was one more. Electrical engineers don't have to take assembly language, so go back. Because I'm teaching two of the new ones, and Humphrey Wamoka is teaching the other two new ones. This is computer science and assembly language programming. There it is. Assembly language programming is one that they said that people should take a Cali. Now, this one wasn't as core of a class. It wasn't like if you didn't have this taken by the time you got to Wichita State, it would hold you up from taking 5 other classes. So it wasn't as big of a deal, which is maybe why I don't get as much enrollment in it. There's only 2 people in it this semester. The introduction to digital design, I think we had a total of 6 people, which was kind of low, I thought, based upon how many engineering majors we have. But anyway, that's the background behind these classes and why they were set up. For the most part, at least on my side, I didn't come up with any brand new ideas on what should be offered here. I stole everything from WSU. And they offered. It wasn't like I stole it and they didn't know. They even gave me their labs. I said, I want to cover the exact same thing that you're covering, because I want people, when they leave here, to be 100% prepared when they go to Wichita State. And they were just as accommodating as can be. And I haven't even redone the labs to put Cali at the top. It says Wichita State. I got to looking, and for the computer science, and I don't know about engineering. I never really looked at that. I assume most engineers are probably going to Wichita State. Maybe a false assumption. But for our computer science, 85% of the computer science majors were going on to Wichita State. So it seemed to make sense to really focus on Wichita State anyway, because that's, I'm not sure if it's a cost or just a geographic location that makes it appealing. Okay. Expectations of this class. Student is either expected to attend the class in person or virtually. If this is not possible, like you work, whatever it might be, then it's expected the student will listen to all of the YouTube lecture. During the lecture that I'm recording, I'm putting it in YouTube format. I may say items you need to know. Like I may say, this is due in a week. And if you don't listen to YouTube lecture, you won't catch that. So you need to listen to it. This is probably more exciting than assembly language programming. I was doing that before this class, and at one point I think I about put myself to sleep. Assembly language programming is not that exciting. It's not as exciting as C programming. If you get excited about programming. So anyway, watch the lecture. Attendance, there is no policy on that. I put down no late work. Now, if I'm working with you on something, then I'll work. Then I may extend it out. But that's more if I don't hear from you and you're not turning anything in type of deal. And I have to know if you're actively working on it and I'm helping you. That's different. The book is See How to Program by Deitel, if I'm saying that right. Does anybody have the book?
Yeah.
You do? Okay. I didn't know if the books. Sometimes the bookstore doesn't order them until the very last minute. They what?
They were out.
They were out? Okay. So again, if it takes them a week to get the book in, I'm going to work with you on due dates. So don't stress about that. It's your responsibility to have a working computer with reliable internet access, must have the ability to install software and be a Windows computer, Windows 7 or greater. If you live in the Wellington area, you're welcome to come in, and I'm here various times in the morning and afternoon. You could work on these computers. I don't care about that if you don't have a computer. Course grade, programming projects, 80%. Final project is 20%. Now, don't stress. That doesn't mean that that's the final project, this horrible thing where I have you write the Microsoft Excel or something like that. It's not as hideous as a final project sounds. I'm not going to sit here and read all this to you. Tutoring, I'd be shocked if there's tutoring available. Pretty much if you were to go to Arc City, the tutors, most of them don't know programming. I think that's a little bit better at Mulvane. Sometimes you have some people that work in tutoring there that do have computer science background. Let's see, blah 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 blah, and then down to the schedule. To be ADA compliant, we can't use boxes anymore, so there's no boxes around those. But so that's going to take me a while to get used to that. And then there's 3 weeks over here to catch up. We may get into C++. That's what the book is into after chapter 14. Or if we need extra time, then we can extend this. So we'll see how it goes. Is there any questions on the syllabus?
What's the final going to be like?
It may be such that in some cases I've made it like a tutoring idea where you generate random numbers and you say what's 37 plus 21, and then they enter an answer. You check to see if it matches. If it matches, you say good job. Otherwise, then maybe tell them what it should be. That's one thing I've used in the past. Sometimes a little database system, a little file system where you save your information in files. it used to be I used to go get my hair cut at some kind of, I can't remember what it was. I keep thinking it's Jay Giles, but I know that ain't right. That's a band. But there was a place in Wichita that I'd go and get my hair cut, and they had a very basic database. They had your name and your phone number, and that was about it. Not sure why they kept the database. You know, a database should be such you do something with it. You know, like you have your email address, so I can email you specials. You know, a mailing address, if nothing else, so I can send you a postcard Christmas time, say thank you for your, you know, but they didn't have any of that. But that'd be an idea, you know, have such that you have a little database type system. So it's not a real hideous thing, but those are two examples I've used in the past.
So it's gonna be just writing a program then?
Right. Yeah, it won't be a test in this class. Any other questions on the syllabus? I think I got everybody marked down. It's here. Okay. Now under course content, I'm recording this in YouTube video format like I indicated. I will put the recording out here in each individual week. So like after we finish this lecture, I'll put it under week 1. So you can go out there, you can listen to it again, and so forth. Under week 1, I'll also put the assignments. And I was ambitious today. I went ahead and put the assignments out there. Hopefully we get that far, and I don't have to change dates or anything. But I went ahead and put some assignments out here. Here's of course the class link. If you're at home, you obviously found it because you're connected. The software installation we'll talk about here briefly. So we'll go ahead and click that. And the software is Code Blocks. And when I went there, I chose the Code Blocks dash 17-12 mean w-setup.exe. And what this does is it not only installs Code Blocks, but installs the compiler, the C compiler. I put on here, I had to go to settings, compiler, toolchain executables, and so forth. Click auto detect to fix any directory issues. I installed it on 5 laptops this afternoon. I didn't have to do that one time. So I don't know what was unique about my computer at home where I had to do that. But it was looking for the C compiler in the wrong location on my computer at home. So if yours is having trouble finding it, you may have to point it to the correct location. Now, Code Blocks. I hope I installed it on this. Yeah, I did. Made sure I installed it on the 5 laptops out here. This is, and again, we're not going to start programming yet, but you can bring it up if you want. If you got it installed here. If you're at home, you probably don't have it installed, and that's fine. This is an IDE. The concept behind an IDE is that it provides additional debugging tools and development tools to help you figure out errors and so forth. I don't know why they have Fortran on here, but somebody at some point must have liked Fortran. First thing we'll do is we'll go over parts of Chapter 1. This is the publisher PowerPoint. It's not very exciting. There's no programming here. And it's 132 slides. I'm not going to go through 132 slides. I'd be asleep and everybody would be leaving at that point. Not exciting. I'm going to jump around. I'm going to talk about different aspects of programming. Okay. By the way, they do say all these example programs may be downloaded from our website, www.detail, if I'm saying their name right, .com/book/ I don't know, what does that stand for? I don't know. But that's version 7. Edition 7 is what the book is. Okay. It's talking about where computers used at. That's probably pretty obvious. Computers, hardware, and software in use today are more than a billion general-purpose computers, and billions more embedded computers are used in cell phones, smartphones, tablet computers, home appliances, automobiles, and more. I thought it was interesting. I don't know how truthful it is, but there was an individual on the news that was claiming that 40% of the repetitive jobs that currently exist, 12 years from now, they're going to be automated. I think the cost has to come down quite a bit on robotics and so forth for that to occur. But there are fast food restaurants now that are completely automated. So you could see where it's all headed. Computers and engineering is going to be the wave of the future, at least until we rise up and destroy them. There's a book, Player Piano by Kurt Vonnegut. I'm not sure if anybody's ever read it. It's a good book. But in the book, the engineers and the programmers and so forth have automated everything to where nobody's got a job. And so the government has everybody out fixing potholes and so forth. And of course, people aren't happy, even if you're paying them to do nothing, just standing around and fix a pothole. And so they rise up and destroy the machines. So you can almost see it happening. Computers can perform computations, make logical decisions a lot faster than people can. One of the for about 3-4 years, I taught for World Quant University, and they offered a free quantitative finance degree. And I did the Python programming part and the statistics part, and I didn't do the real hard stuff. But part of it was machine learning. And they somehow incorporated machine learning with the stock market. And so it looked at the patterns of the stock market, it learned by itself. And that helped them then to predict, what should they invest in. And I developed 2 of the courses and taught those for quite a while. Some kind of billionaire, that was his pet project to offer this free degree. And mind you, I didn't get paid billions, but at least I got a couple of trips got one trip going out to Columbus to do some recording on it. But that's, you think about it, you have a computer sitting there analyzing the stock market and telling you what you should be investing in. So, it's just things are changing. It's talking about the speed here and so forth. Software, that's of course what you'll be writing, programs. Okay, so everybody knows what a keyboard is and mouse. And, computing costs are dropping dramatically. I'm not sure if that's quite true. I suppose it is. I forget what's the newest i9? Is that the newest one out? Yeah. The prices on those don't look real cheap to me. I want one real bad. But they're still up there pretty good. But then again, the processing's really increased. So I guess the price per whatever cycle you're looking at, whether that's speed or storage or whatever, is dropping. Talks about computers that used to fill large rooms, now are real small. We all know that. Many decades, hardware costs have fallen rapidly. Okay. Moore's Law. input unit, output unit, memory unit. What do you think is more important? Memory, RAM, or your memory that's your hard disk? RAM? Yeah. Some people
That
might
depends on
disagree.
what you're doing.
Right, exactly. If you're doing some applications where you need a huge amount of hard disk space, then that would be. What I do, I always go with the RAM. I try to store as little as possible on hard drives anymore. Um, I get lazy and I don't delete them. Like I'll leave that assembly language lecture out there forever. I don't know how big 2 hours and 22 minutes is, but again, things you have to think about, and when you're buying a computer, what's more important. Now, there's different types of hard drives you can buy that really speed up your performance on your it loads your programs fast and everything. The what? The solid. Yeah, is that what you? Okay. Yeah, I haven't got one of those yet. Seems like every computer I buy, I get at Best Buy, and they're too cheap to put that hard drive in there. Yeah. I'm too cheap to go out down and buy a new hard drive to replace the one that's there. It really speeds up your computer, is what they tell me?
I mean, it loads up faster. It loads everything.
Okay. Data hierarchy. When you're talking about a computer, you see it's got a series of zeros and ones here. That's how your digital device talks, is with the zeros and ones. That was part of the introduction to digital design course that we offered for the first time last semester. Is it introduced that concept, which was real interesting. And I know better than this, but I always envisioned that you had an electronic device, you had zeros and ones going across. What's really the zeros and ones?
It's kind of logical number.
It's a logical number, but it's based upon what?
The binary system.
Binary system. But it's voltage. So if your voltage is so high, it's considered a 1. Your voltage is so low, it's considered a 0. And when I was reading this, it's just like, well, geez, that says full of error. If your voltage goes up or down a little bit, then all of a sudden it's a 1 instead of a 0. But there's error correction built in and so forth. But that was an eye opener. I guess I never really thought about what does a 0 and 1 really mean. Electronics, you have voltage going through. Talks about bits. The smallest data item in a computer can assume the value 0 or the value 1. Such a data item is called a bit, short for binary digit. A digit can assume one of two values. It is remarkable that impressive functions performed by computers involve only the simplest manipulations of zeros and ones. Examining a bit's value, setting a bit's value, and reversing a bit's value from 1 to 0 or from 0 to 1. And let's talk about the characters, fields, records, files, databases. You get into working with, if you're going into computer science, how many of you are going into computer science? Some of you are. Working with databases is probably, I worked as a computer programmer for 13 years. That's probably 75, 80% of what I did. Anything you're doing important, you want to save it off into a database. Why lose it? So most of my work was database work. Database is kind of the big conglomeration of everything. Within that, you have your tables, or you could call them files. And then within the tables, you have further breakdown, records, and then within the records, and so forth. That's a challenge. Kali is facing that now. We got this new system, Genzabar, and people don't know quite how to report on it. And I'm learning that myself. I'm brushing the cobwebs off of my SQL. How do I do these queries and so forth? How do I get unique? And I kind of cheat. I use Excel to come up with it. But retrieving data and storing data is important. Programmers write instructions in various programming languages. There is C, C Sharp, Java, whole slew of programming languages. If you are going into computer science, best site you can go to is one called dice.com. I always tell people to go there themselves. I'm sure there's a website for engineers. I couldn't tell you what it is. But dice.com is for computer science majors and people going into IT. And if I'm trying to figure out what skills to pick up along the way, what do you think is the top programming language? What's the top programming language people are looking for? C? Java. Oops.
Probably C++ or...
No, it's actually Java currently. Now, this isn't every programming job across the United States, but of the ones that are out there now, there's 17,314 open jobs for Java. So quite a bit of demand. Now, C is 4,770, so it's less. C++, I'm guessing, is even less. Lie. It's more. 6,078. C Sharp, 5,610. SQL. Some of you may have taken the SQL class last semester. 19,217 jobs where they want you to know SQL. Because like I said, about everything programming involves SQL in some manner. So I always tell people, go out here, if you go into computer science, research it yourself, see what they're looking for. This should be your constant companion if you go into computer science for your entire career. You should constantly look to see where it's going. I have no clue what this is. I should, but I've never done anything with it. I want to, but this name's been popping up a lot. Jeez. 16,811 jobs. They want you to know that technology or whatever that comes to. I think it's a development. I don't know. Now this doesn't have so much networking stuff in it. Like I'd be surprised if there's much Network Plus. 225. This is probably geared more a little bit on the programming side. So this kind of tells you what people are looking for. Never trust what anybody tells you. Now they've changed, but about 10 years ago there was a college in Kansas that COBOL was their big focus. How many jobs do you think there are that are looking for COBOL programmers?
Not a lot.
Not a lot.
4.
Yeah, that's about
Probably
right.
the only one are legacy applications.
Yeah. 335. So, I would not want to go to a college that was teaching me COBOL programming. That's not very many jobs considered across the entire United States. And all the COBOL programmers are grabbing those up probably just as fast as they can because there's no market for their skills anymore. Fortran, I'm surprised that's that high, but 119. JavaScript. You might be surprised by this. 11,057. JavaScript's really be taken off. And I'm not sure really understand the draw of that because I'm so geared to with a paradigm of thinking JavaScript is just enhancing a web page. But I know it's much more than that now. Anyway, good site to go to. Find out what engineering, if you're going to engineering, find out what is a good site to go to. Along the way, pick up those skills. Keep evolving. You don't want to become the person that's obsolete and that's sent out the door. When first time I worked out was Koch Industries, a KOCH in Wichita, and I worked as a COBOL programmer. And Windows was just come out then. That shows you how old I am. And Visual Basic 1.0 came out, $100. And I thought I got to get that, and I don't know what it is, and so forth. But I bought it, started playing with it, developed Windows programs, and I downloaded mainframe data using a Windows interface. Gave it to the users at Koch Industries. They loved it, and they went to my manager and they said, "Boy, we love what David's doing." I said, "Well, what's David doing?" I hadn't got approval through him. He wasn't very happy about that. Kind of chewed me out a little bit. He said, you really need to run this stuff by me before you just go and do it. So I'm sorry, I didn't realize I was supposed to do that. He said, but they love it, so keep doing it. Why didn't I go through him, do you think? I figured he'd say no. Yeah, it's much better to just apologize afterwards, because I knew it was the wave of the future. And so I moved into programming just Windows applications. It was probably 6 to 8 months after that. They fired 40 COBOL programmers, sent them out the door. I still get those resumes now here at the college. They send me the resumes on because they couldn't tell you what COBOL is versus Java versus anything in human resources. So they send me the resume and say, is this a valid one? And I see these people that did not keep their skills up. Now I suspect it's the same with engineering. You don't want to become obsolete. Okay. Let's see. There's machine language. If anybody ever programmed in machine language, ones and zeros, that was before my time. I'd be shocked if they did. Maybe they did. Let's see. English-like abbreviations to represent it. They formed assembly languages, and so that's why I was teaching at 4 o'clock. And it's pretty low-level programming. Doesn't mean you won't do it. Like some of the electrical engineers, they'll get into assembly language sometimes. Assembly language allows you to talk directly to registers on your device, and so you get very fast response. Some game development uses that. Because there's like one game in particular, the Warriors. I haven't played it for 10 years, but you go across and at one point in time, all these gang members come and attack you. Must be 20 of them on the screen at one time, and it's so slow because there's so many people on the screen at that time. It's almost unplayable. That's where in game development they'd write that particular segment in assembly language. So it's talking directly to registers and CPU and all that, and you got that performance gain. Although assembly language code is clear to humans, it's incomprehensible to computers until translated to machine languages. Because again, it doesn't understand assembly language. You have to convert it. Compilers. Compilers will convert your high-level language programs into machine language. Scripting languages, JavaScript and PHP are processed by interpreters. Definitely a good chapter to read over. Okay, down to the C programming language. C evolved from 2 previous languages, BCPL and B, and I've never used those, never have even read very much about them. BCPL was developed in 1967 by Martin Richards, language for writing operating system software and compilers. Ken Thompson modeled many features in his B language, and in 1970 used B to create early versions of the Unix operating system at Bell Laboratories. You see his name in the history quite a bit. I don't think I've heard of Martin Richards very much. Why is Unix important? What did it become or evolve into? Linux. Yeah, so which is huge now. All of our engineers, electrical engineers at IFR, that's all they'd use is Linux. They scoffed at Windows. We had Linux engineers. That's all they did was keep those servers up and running for the engineers. C language was evolved from B by Dennis Ritchie at Bell Laboratories, originally implemented in 1972. He wrote a book on the C language. It's kind of a famous one. Many of today's leading operating systems written C and or C++. C is mostly hardware independent. Okay. C is widely used to develop systems that demand performance, such as operating systems, embedded systems, real-time systems, and communication systems. Talks a little bit about where it's used at. Here's the famous book he wrote, the C programming language, that drew wide attention to the language. Used to have that book. I got rid of it though. 1989, C standard was approved. The standard was updated in 1999, is often referred to as C99. Still evolving a little bit, but not very fast. New C standard, referred to as C11, refines and expands the capabilities of C. Because C is a hardware independent, widely available language, applications written in C often run with little or no modification on a range of different computer systems. This assembly language that, like I was referring to for that previous class, this is specific to a type of architecture for the hardware. You cannot do it on every type of architecture. So it's very specific to the ARM. This is saying with C, you can pretty much run it anywhere. So that's a benefit of it. You don't want to have to rewrite every program if you go into a different framework for your systems. Let's see. Let's talk more about that. Talked about C++, other C-based languages. Like I said, a lot of things are based upon C. Objective-C is one that's, I think, used on Macs. Visual C#. I like C#. I'm hoping to see it eventually pass C and C++. Even though you kind of are geared to the Microsoft world, although there is flavors of it on Linux, it's really meant for Microsoft. Java, PHP. I didn't know that was based on C. All these do a little bit different. Java's kind of set up to run on different systems. I'm really surprised Java has taken off like it has. I thought it would die out. Idea of Java is that you got a program written, and then you got libraries on each individual platform, and those libraries allow you to run that program. So you have to install those libraries before you can run your Java program. So that way, it's kind of you write it one time and it can run on anything. Nice idea, and so forth, but it doesn't always work just as good as it sounds. PHP is a scripting, mainly used for accessing databases, but I suppose you could use it for a lot of different items. JavaScript. Let's see. Objects. Like I say, I don't want to spend a huge amount of time on this stuff. Methods and classes. Objects, probably more important in some of the other programming languages than it is in C. C is not designed as well for handling objects. You have to really work hard to probably even implement them. There's a game. I went to that. There's a video game place in Wichita called the Arcade. Went there last Sunday and took my son and his friends there, and I played myself because I like those type of games. And there's one where there's you're chased by these robots, and in the game there must be 25, 30 robots per screen, and you shoot all around trying to kill them. I'm not even sure if I saw that game this last Sunday. But the idea is all those robots look the same. So instead of having 30 separate objects on your screen, you have one object defined that this is what the robot looks like, and then you create instances of it. And then you program those instances. So it really helps ease the programming. I doubt when that game was developed that they actually had object-oriented concepts in place. So it's probably they actually have variables for each one of those robots. That'd be the idea. You go into a grocery store, you go into Walmart, and you got those cameras on the ceiling. If you wanted to automate it, the idea would be that a human is an object, and each person that walks through your store is an instance. And so that the computer program, when you walked in the store, they'd create a new instance of a human, and it would watch you as you went around. And if it saw you pick something and put it into your coat, then you'd be flagged. I would hope that eventually that's where the technology would go, that there isn't somebody manually looking at 200 people in a store trying to figure out who's shoplifting. That probably is the case. Actually, probably nobody's watching the cameras, but anyway, that's the idea behind object technology. Works real well with game development, and can work real well in a lot of different areas. It talks about phases, edit, preprocess, compile, link, load, and execute. Editing a file, talks about creating it. Too widely used on Linux systems are, I say that, Vi? Emacs? Not sure how you pronounce that. I hate that program. Have you ever used Vi? Nasty program for Linux. There's a better one I like. I always install it instead of using that silly thing. Pico. I'm not even sure how you say it. It's Pico, and it's a very easy editor to use. This is a lot of cases a line editor, so you edit it line by line, and so it's just harder to work with. It's not like Word where you can use your down arrow and edit it and so forth. At some point in this semester, I'll torture you by making you go out and use a Linux system, because they do use C at Wichita State, but they're very big in Linux, and so you should know how to use some of these editors. So part of what you'll learn this semester, maybe those last 3 weeks, we'll focus on some of the. They're not hard. You just got to remember a lot of stuff. Let's see. Eclipse is a nice development environment. I've installed it, but I've never used it. It's a beast. Lots of options. You can do about anything under the sun with Eclipse, but it's not easy to set up and configure and everything. Visual Studio. C program file name should end with .c. Okay, so you compile it. It talks about the preprocessor. Syntax errors when you get a issue. You're programming. You got something wrong with it. You got compile errors, compile time errors. We'll talk more about the errors. Linking. GCC. That's a what? Compiler. Yeah, that's what CodeBlocks is set up. So I think it was under settings, compiler, and tool chain, and it is working with GCC. Although you can, through CodeBlocks, you can point it to any compiler, but that's a big one. If you're on Linux, when you write your program in whatever cryptic editor you have, and then you compile it by doing GCC space and then your C file name. And it creates an executable and so forth. You can run it and all of that. See here it says if a program compiles links correctly, a file called a.out is produced, and then that's a program you can run. Now there are nice editors in like Ubuntu and some of those, so you're not limited just to these. But the idea is that you may not have a nice graphical interface like Ubuntu. Why is a Linux? Why do engineers like Linux so well, and a lot of the world? Windows is so easy to use.
Is that a question?
Yeah.
It's because of the speed of using a keyboard rather than a mouse, right? It's more efficient.
Some people love that. That's one of the reasons. Security. Whenever you have a GUI, a nice graphical user interface like this, where you can click on it and so forth, it's nice to use and so forth, but it opens up ports, opens up holes into your computer, so people can hack in. So a lot of people don't like that poor security that it does. If you're working with a server, oftentimes they won't even put a GUI on there, a Linux server. You have to use the command lines and everything. When you put that GUI on there, then it creates issues. At IFR, we had a Linux server of some sort for our Oracle database, and it was a GUI because we didn't want to use the command line because it's hard, remembering all those commands and so forth, and so we had that GUI. And you might say, well, why would you open up all these security issues with your database? Well, our database was internal. So no external applications was using it. So we figured that our own employees wouldn't hack in and do something to our database. So that's why we had that. But if you had a server that was used externally, you don't want to have a GUI on it. It talks about loading. We'll talk more about that when we get to. Here's how you run your program. In Linux, you do ./a.out, so forth. Problem may occur at execution time. Programs do not always work on a first try. I used to think that sometimes they just randomly don't work. And I always thought there was like demons in the system. It never made any sense to me because I'm a logical type person. It's just like, how can it work 500 times and then the 501st time it doesn't work? I wrote a Visual Basic program at Coke that would upload general ledger entries. And they loved it because it was Windows based. And, it was really easy. Anybody coming out of any basic programming class could have wrote it. So it wasn't like some genius program I wrote. But it crashed every now and then. I'd maybe hear from them every 2 or 3 weeks. I'd get a user call me, say, yeah, it crashed. And they'd tell me what the error said. It would say, file not found. And I wasn't accessing a file in a program where they were running it. Never could figure that out. Left Coke, and I suppose it kept on breaking. It makes more sense now when I understand about the voltage and the ones and zeros. That maybe it's just voltage was a little bit too high, and that's what causes it to kind of flake out sometimes. So some of these demons in the system make more sense when you understand that. Maybe that's why Wichita State wants you to know that underlying structure of it, because then you know that's why it's breaking instead of it driving you crazy. Programs are always working on first try. Okay, if you look. A lot of bad programmers in the world too. Even good programmers put errors in their code. It was 15 years ago. Microsoft Excel had issues. Microsoft Excel's been around forever, and 15 years ago when I worked at IFR, Excel was such that if you had a user that kept taking it down and loading it all day long. A program is supposed to free up the memory when it's done. It gives the memory back to the operating system. Microsoft Excel did not do that. So each time you brought it down and brought it up, it took away more and more of your memory on your for your operating system, until eventually it crashed, or it just ran so slow that it was unusable. We'd get calls from the users, and they say, "Yeah, my computer's just been started going slower and slower as the day went on." And we'd ask them, "Did you go in and out of Excel?" And say, "Yeah." Well, I said, "Just reboot your computer; it'll be fixed." Here's Microsoft. The geniuses of Windows, and they can't even write the program right. So yeah, a lot of errors pop up. We'll be talking more about standard in, standard out. Test drive in a C application. Like I say, I'm not spending a whole lot of time in this first chapter. Mid-1980s, Microsoft developed the Windows operating system consisting of a graphical user interface built on top of DOS. Enormously popular personal computer operating system of the time that users interacted with by typing commands. It's a proprietary operating system. It's controlled by Microsoft. Linux is an open source. Open source allows a lot of benefit. What are benefits of open source?
Anybody can edit and
No license. Yeah.
They have access to the source code.
Right. Have access to source code. Which means, in theory, I don't know if I agree with this, but in theory, it's more secure. Because you can go and look to see what the holes are, where it's going to crash, where people can hack in. With Microsoft, you can't see the source code, so you can't see where people are going to hack in. I say in theory. Do you think many people in businesses spend their time searching through the source code for Linux, looking for issues? No. Who probably does? Probably hackers. So that's what I'm saying. I'm not sure if I agree with that idea because, students, you guys have a lot of time. I don't know. You're struggling trying to get everything done and work, on top of taking classes, and you probably don't have time to sit at home and pour through tons of C code looking to see what's going wrong with the operating system. So, but that's the idea behind it. It's more secure. I suspect it does get hacked into less security issues, but I almost think that's because people hate Microsoft so much that they look for issues than it is the structure. But I don't know. I could be all wrong about that. I don't have to do it at a community college level, which is fantastic. But when you're at a professor at a four-year college, teaching is not the main focus. So they actually get in trouble if they teach too much. They're supposed to do research. Like if you're in education, you research a new way of teaching or something like that. If you're in computers, oftentimes your research is maybe working on an open source project. And so that's why you see professors working on this and so forth, because that satisfies their research component of their jobs. Talks about Apple there. Okay. Google's Android, Internet, packet switching. That's kind of an interesting concept. Packets themselves. whether it's through your network or it's over the internet. If I were to put out that 2 hour and 22-minute lecture I just created earlier today, put it in MP4. If you download it, how's it coming across the internet to you? Packets. It's broken into pieces. And then, when it reaches its destination, it's kind of brought together. And that's the idea behind that is, otherwise I'm sitting there and I'm transmitting this huge file, and everybody else is blocked out. They can't do anything. So packets is a fantastic idea they came up with to provide that. It's interesting with the packets also, examining what's going across. You can see potential hacking, that's being done, people modifying. Got your World Wide Web. The internet is your backbone, right? And World Wide Web is software. You got your hypertext markup languages. How many markup languages are there? Ton? Yeah, I couldn't even tell you how much. If you were to go out there and look at the different markup languages, there's Cold Fusion markup language. Cold Fusion has kind of died out. It would look like it was going to take off for a while, but then kind of went away. Fountain, spacecraft markup language, voice XML, virtual human markup language. And that's just a few. Here's where you get into really the list. Tension.xml, auto lead data format, beer XML. Free XML based data description standard for the exchange of brewing data. It's a free, fully defined XML. Interesting. I'm not seeing a markup on it. Oh, there. /hops. Tons of markup languages. This allowed us to be able to pass information easily, such that a web page is just text. So it's a markup language. You pass it based upon just what those texts say. You can then display whatever. XML is a big thing. You always should learn a little bit of HTML if you go into computer science. I don't know about engineering. Probably wouldn't hurt. If I come here and type in HTML in DICE, you see there's quite a few jobs, 7,231. Nobody's going to have you develop their website using HTML. You don't do that by hand. I did that for a period of time. This was back in the early days. They asked me to be the webmaster at IFR, along with my other duties. And the person they had was really irresponsible. He was operating out of his garage, and he's very flaky, wouldn't do the work. And so they said, "Hey, can you do this?" And I said, "Yeah, I can do that." And I used a package called Front Page. I'm thinking of the right term. It's been a while. And it was great. It was GUI and so forth. And I put the website out there. It looked great. Started getting call after call. There was two main browsers back then. There was Netscape and there was IE. Looked great on IE, Microsoft's version. Looked horrible on Netscape. So every customer we had that used Netscape would call up and complain. And I'd received so many calls, I finally couldn't take it anymore. And so I just started doing it by hand. because front page put Microsoft extensions in there. And finally, the Adobe came out with PageMill, and PageMill was very. There was no front page, there was no Netscape extensions. It was just pure HTML. They were the first ones that had that purity to them. And I used PageMill at that point. But again, when you're working with these, they want you to know the technology, because not everything's automated. You'll probably have to write HTML out through a program. XML. I'm guessing it'll probably be more than HTML, but let's see if I'm wrong. Less. I figured it'd be more than that. But XML is the big way of exchanging data now. Let's see. What's a URL besides Uniform Resource Locator? Yeah, www.cali.edu, right? So I'm assuming everybody knows that. What's great about HTTPS? More secure. Yeah, if you see that S on there, that means it's more secure on the internet. Just says HTTP, then you probably don't want to be working with them too much. Used to be you could find sites pretty easy that said HTTP, and they'd have logins. If it was HTTP, there was no padlock up here, and it had a login, what was going across the internet? In plain text.
All your information.
All your information. Yeah, plain text. There's no encryption to it. So if you were on your laptop and and I had there's programs out here where I could monitor it. I could see your password and everything going straight across. Used to be Facebook was HTTP. And probably none of you are probably old enough to really remember that. But when I taught computers 12 years ago, 10 years ago, I forget how long, we would bring up Facebook, and we'd have the monitoring software over there, so we'd watch what was going across, and it'd come up as HTTP, and it wouldn't be encrypted. Now, if you screwed up your password one time, then it went to a page that was secure. I never understood why in the world they did that, but it's hard to find those anymore. Most people have a pretty good idea of what that means and so forth. There was a candle store that sold candles on the internet. I used to like to go to them, pick on them, because they had HTTP and very unsecure. Okay, talking about the history. That's not that exciting. Ajax is one you hear fairly often now. Agile development. Again, I can read some methodology and so forth, set of methodologies, but I haven't played with it, so I really don't even understand it. But again, that's becoming quite popular. If I was going back into the computer area, computer science, at some point I probably want to learn a little bit about that. Just keep my skills up. Don't want to be the COBOL programmer they send out the door. LAMP. Linux, Apache, MySQL, PHP, LAMP. So you see that term quite a bit. That's a combination that people like. There was one I downloaded the other day. It's still around, and it's easy. And that's why I wanted something easy. And WAMP, if I'm saying that right. Have you ever heard of WAMP? Windows. Apache, MySQL, PHP, WAMP server. It runs all of that on your Windows machine, so you don't have to load in Linux or anything like that. Haven't done very much with that, so I couldn't even really comment. Platform as a service, haven't done much with that. Alpha, beta. Okay. Talks about different places where you can keep up. That's it for that chapter. Now, this class is 3 hours long, so about the halfway mark, we'll have a 10-minute break, and then we'll do the second half. So we'll go ahead and take a 10-minute break, and then we'll start again. So if you want to use the restroom, it's and you're in Wellington, it's right down the hallway there. If you just need to stretch your legs, then you can do that too. And we'll get into exciting stuff, or more exciting stuff, with chapter 2. The what? It's wiring from the 60s. That's for your internet. They didn't really ask the computer people when they designed this room. Yeah.
It was confusing coming in today. We went to the other side and I was like, there's so much.
Oh, yeah. Mind you, I'm not complaining. I love this lab, but proper computer lab has a raised floor. You put your wires underneath. You don't have carpeting, especially if you're going to work on electronics. That static discharge is not good. But Callie's never had a computer science lab before, so this is our first one. I think they got to looking how many job opportunities there are in the computer science area and thought, this is an area we really need to focus on.
into the slides? Is there a way we can do that? Like I missed it the first time.
I can put them out there for you. Do you want access to the slides?
Okay, I didn't know if like you were on code blocks and then you went to the slides and I didn't know if I somehow missed it getting to them. So.
Oh, no.
Okay. Do we have any sort of like test over this type of stuff, or is it just more hands-on?
Hands-on.
Okay.
The Dytel books is very big on definitions. Like each chapter used to be. You might find there's 100 definitions. And programming isn't geared around knowing all those definitions. There are some important ones, kind of the ones I hit upon. You should know what a GUI is, IDE, those type of things. But the slew of ones that have you memorize is just ridiculous. I don't know if they still do that or not.
So on our assignments, like how are we gonna like know the thing?
I'll show that. See, like from a programming standpoint, people should, when they hear packets, maybe they don't understand the exact detail of it, but they should understand what a packet is and the benefits and so forth. Being able to define what all these items are not that important. A lot of this you pick up as you go along. I don't even know how many definitions they have there. Yeah. Yeah, like I say, Dytel's kind of big on definitions. They put them here, but programmer. I think it's been about 10 minutes. So let's go ahead and start again. This is Chapter 2, Introduction to C Programming. And I'm going to kind of skip around again. Now, this is our first program in C. And I'm going to go in code blocks and put this. If you don't have code blocks, don't stress, and so forth, because this is a YouTube video. You can access it later on. And I can put these slides out if you want. Let me highlight that. It doesn't. That's great. Why wouldn't you make that so I can copy it? Within code blocks, and this throws me on code blocks. I keep looking over here for file, new project, but new project, I thought it was over here. Maybe it is over here. File. Oh, there it is. Yeah, file new project. Oh, I know what I'm thinking. I'm thinking of assembly language. Comes over here, and you can choose an empty project. Click go on that. You don't even have to have a project on this. Give it a title. Put it in whatever location. Someplace I clean up. Oh, there it is, desktop. So I put in my desktop. Again, you can create a folder. If you come here, you click new folder, and C programs. You just want to save it somewhere where you can find it. I don't know if I clicked OK on that. It says new folder. That's fine. You can give it a title, so forth. Let's see. Project. Tells you your project file name, so forth. Click next. You click finish on that. And that throws a new project out here. Now, if you do a file new, an empty file, you can put a file in there. You do not have to go to that effort with code blocks. Like if I had, where in the world's close? There it is, close project. If I just have this right here, if I do a file, new, empty file, then you could just have your C program right here. Over here has // a first program in C, has pound include, .h, and I'll put all that, main void this, and then a printf. Welcome to C, and have a /n, yeah. Now, if I save this, if I do a file and save file, you see how it says untitled.c? That .c is what tells us it's a C file for our purposes. I'm going to name this hello.c. And then click save. Now, if I come up here and under build, there's a build and run. So the build creates the executable and the run runs it. So this is probably the one you want to use the most often. If you have a good memory, you just press F9. So if I choose that, you see it says welcome to C. So that's our first program. Well, let's talk about this a little bit. This // here, that's a comment. A comment is where you document what's going on in your program. It does not increase the size of your program. It does not make it slower. So you can put as many comments in there as you want. When the compiler goes through, it cleans those out. So it doesn't actually put that in the executable. It's just there to help you. It's debatable on how much documentation you want to do. I would not do a whole lot in this class. Pretty much you do documentation if you got some really tricky bit of code that a year from now you're not going to remember, have any clue on what you did. That's where you put your documentation in there. Worst thing you can do in the world, and this happens so much in programming, is people who put nice documentation in there, they write their program, then 2 months later, they're under pressure to make a change. So they go in, they make the change. They need to get it in there fast. And what do they forget to do? Right. So your documentation says one thing, your program says another. And then a year from there, you have a programmer sitting there scratching their head, and it's like, I don't understand. This doesn't make any sense. The documentation does not match what the program is doing. And it creates more confusion. A better way than to document every single item is to use proper names, proper programming practice. I did not use proper programming practice when I slapped this down here, and I'll talk, at least one place. But again, you can put whatever here. // you can have multiple lines. This is line 2. Now, I don't know what color that is, because I'm a little bit colorblind. Gray, light blue, something like that. This is an IDE. Interactive development environment, where it puts this as a different color so you can easily see that it's a comment. You won't see this like in a Linux where you got just a command prompt. Everything will be the same color. So again, that's the thing that helps you. I went out of town a week and a half ago, 2 weeks ago, and I took 4 books, computer science books, so I could prepare for the coming semester. I took 2 laptops. Did I take 2 or 3? God, I think I took 3. Yeah, I took 3 laptops because I wanted to have the Mac, I wanted to have the Windows, and I wanted to have my own personal laptop because I typically don't try to do a lot of personal stuff on this one because it's school property. So I had 3 laptops. I would like to have taken my PlayStation with me, in case I had time to play it. I'd like to have taken my Nintendo, so forth. If I wanted to take everything that I could potentially use, what would happen?
You would run out of luggage space in your car real quick.
Exactly. And that's the way it is with programs. You typically just want to bring in just what you're going to use. And this right here, this include, this brings in code that somebody else has written such that you can use it. I could sit here and have tons of include statements and bring everything in. But then my program would be so big that it'd run slow, it'd be huge, and so forth. And that's the general idea on programming is bring in just what you need, not everything. So there's a whole bunch of libraries we could bring in. We bring this in so we can deal with input and output. That's what allows us to do the printf. You notice that here the pound include and then the less than. And now good IDs, I don't know if the Code Blocks does this or not. If you type include, it does. See how that pops up with that? Different books call that different things. Different packages call different things. Some books refer to it as code completion, which means once you get to the point where it's highlighted, you can press your tab and it completes it for you. Notice how I did a less than there and it popped up with a list of items, didn't it? These are all the different libraries I could bring in. I have no clue what this is. I never have used it. I'm assuming it's video libraries, such if I wanted to play video in my program, I could do it. I'm guessing. Tons of code I could bring in. But why bring in video code if I'm not going to actually play video? Jeez, how many is there? Now, the good news is, as a computer programmer, you don't have to know every one of these. If you did, it would take you 5 years to master C programming. And that's what you don't want to get overwhelmed. You don't want to sit around, no way I can learn all this. You don't have to. Most of your basics you revolve around just certain aspects, certain libraries, certain commands, so forth. Somebody asked me earlier today to do a switch case switch statement in C#, and I don't really use those because I don't like them. I think I only used them one time in the production environment. I like using the if statements and so forth. It's just easier. It made sense where I used it at because I was programming a barcode system on a production floor, and we had so many possibilities that it would probably been about 30, 35 if-else statements, and it just didn't make sense there. So that's where we used it. But again, I had to Google it myself because I didn't remember the exact syntax. Now here, this is our main program that we're running. So when you run it, this is the main one, just like you might think. This in front of it says int. That's a number with no decimals, like 5 or 7. Gets a little bit confusing. Some programming languages refer to it as a decimal integer. Does that seem a contradiction? Seems like it, right? You know, integer we're used to doesn't have decimals. Why are you calling it a decimal integer? So in some cases you see it creep up where you use a D, and you're sitting there that. Well, I never have read the history on it. I'm not interested enough why they call it a decimal integer to actually research it. But integer is a number with no decimals. So why do they have it in front of the main? After this gets done running, it's going to return a number to say did it work or not. If I run this, if I do a build and run again, though I could have just done a run, you see it prints my welcome to C. It says process returns 0. That 0 indicates that it was successful. Doesn't mean a whole lot right now, but it will later on. Void. If I trying to think of an example. Probably asked my son at least last night or night before. I asked him to put pop in the refrigerator for me, because I pay him some extra money and so forth. Not really an allowance, but I suppose it is. And he does a lot of things, take care of the dogs, do the things I don't want to do around the house because I'm too lazy. So he puts my pop in the refrigerator, so I have cold pop in the morning because I love pop. And I say, go put the pop in the refrigerator. He goes and puts the pop in the refrigerator. He does not return anything to me. He just goes to his room. I know it's done. Void is where nothing is returned. That's what that refers to. I could ask him, and I think I did ask him a couple nights ago. I said, go ask your mom this. I'm off real lazy. I said, go ask her, this. And he went, asked her, and he returned the information to me. So that's where you're returning something. So void's nothing's returned, or nothing's even passed in. Now, you see here we have a beginning curly brace and we have a closing curly brace. In programming, this indicates a separation of something, such that you're grouping lines of code together. And we'll see this in many, many different places. In this case, it indicates just the code in here. What in the world did that do? Let's see if I can do it again. Now that I wanted to do. With an IDE, oftentimes you get these. There it goes. Fantastic. You get these pop-ups. And they drive you crazy when you first get into programming. You think, here it just keeps popping up with these windows and so forth. Get used to it. You'll love it in the long run. At first it's kind of discerning because it blocks things and so forth. Usually Escape just closes it anyway. But there are meaningful tips to help you figure out how to write something. So they really are beneficial. The printf, what this does is it prints to the screen. We're going to see the F, you can do formatting. You see there's a welcome to C. And this has quotes around it. We have different data types, and if you have quotes around it, that's a string. A string is where you have letters, numbers, my name, David Hayes. That's a string because it has letters in it. My age, that's an integer. You might argue that it has decimals, but we'll say it doesn't have any decimals. So that's an integer. So welcome to C, and then there's this /n. That refers to new line. That goes to the next line. If you don't have that there, it still runs just fine. So if I do my build and run, see, it still runs just fine. It really comes into play more if you're going to have 2 lines there. For example, I love C programming. Now, if I run this, if I do build and run, see how it slapped them all together? Welcome to CI, love C programming. That /n makes it go down to the next line. Now, I never can remember which slash it is. I usually put the wrong one. I'll put this one instead of the other one. I think it was this one initially. That's the new line. If you put 2 /n's, that goes down twice. Let's see, build and run. Make sure I got the right slash that time. See how there's an extra line there? So now printf has a beginning parentheses here, has a closing parentheses. And then the line, the statement ends with a semicolon. For most items, you need a semicolon here at the end. Let's get rid of a semicolon. That's disappointing. Let me try running it. A good IDE puts a little red squiggly under it if you screwed up. That's what I was hoping for code blocks. Mind you, if you go use GCC on Linux in a shell, command shell, you're not going to have any red squiggly underneath. But this is what you would expect to see in Linux. You'd see this cryptic thing here. It says error expected, semicolon before printf. And it says line 7. So I'm down here in line 7. You think, okay, well, it tells me to put a semicolon before it. I don't know if this will actually work or not, but let's try that. Do a build and run. And it did work, didn't it? Typically, where you put the semicolon is here at the end of the line. But I guess it doesn't matter if it's at the beginning of the next one. So sometimes the error message down here is meaningful. Sometimes it doesn't really give you anything. Is there any questions on that first program? Okay, let's talk. I already talked about that. The //. Oh, by the way, comments are nice. Like if I got something that's not working, I can comment out that line like that. That's a fantastic debugging tool. Or sometimes it's not debugging, but maybe this line would actually go out and update the database. And so while you're testing, you don't want it to sit there and update the database over and over. So you'll comment out that line, that particular lines of code, so you can then test it. Good IDEs will allow you to select multiple lines and comment them out all at once. And I haven't really looked to see if this is here. I'm guessing it is. That kind of looks like right there. But that's where you highlight this and you choose, see if that's, no, that's not it. Maybe this doesn't have it. I'd be shocked with all these features up here. It doesn't have a comment out all these lines. That sure looks like it. Maybe it's C++. Language start running together for me. slash asterisk asterisk slash multi-line. That's what I was talking about. I said that this looked like, that's slash asterisk asterisk. If I want to comment out multiple lines, you do slash asterisk and then asterisk slash like that. This starts the comments. This ends the comments. I never really use those very much unless you have like 100 lines of code you want to comment out. Pretty much I use the slash slash at the beginning. This talks about how this is a preprocessor directive. Include the standard IO.h. It's a directive to the C preprocessor. Lines beginning with the pound sign are processed by the preprocessor before compilation. Line 3 tells the preprocessor to include the contents of the standard input-output header in the program. So it's bringing in that code, and so you can use it. You can have blank lines. You can have white space. You can have however many lines you want there. So it's kind of up to you on your spacing. I said that I wrote this poorly in terms of design. Typically, you do indentation. Like here, I would indent. And you probably have people argue that you should indent 3, you should indent 4. 1, 2, 3. 1, 2, 3. There's 3. If I put 4 in there, is that any better, you think?
Are you using spaces or tabs?
I'm using spaces. A lot of people like tabs. I don't use tabs. It's a weird story. Took a COBOL programming class at Fort Scott Community College, and during the summertime, and he didn't really want to teach, so he just had us type programs out of the book. And when I was doing it, I would use spaces. I'd space over the lines of code, and mine worked perfect. Everybody else in the class wasn't working. Turns out they would press the tab. When you do a tab, it puts an invisible character there. Most of the time, that doesn't mess you up. Like this is set up such that it excludes those. But some programming languages, if you have that invisible character and that tab, it'll take that as a code, and your program will be screwed up. So, like I say, after seeing that entire class burnt with that, I always do spaces. But tab is the most common one in most of these editors. Interestingly enough, I took a Java programming class at Wichita State some 15 years ago. And it was the same type of thing. He got laid off from Beach, Raytheon. He didn't want to be there. He just had us type programs out of the book, just like before. Maybe you have to have something wrong with you to go into education if you're in computer science. I don't know. I took a $21,000 pay cut to go into education from working as a computer programmer, and I wasn't very aggressive. I was making about $65,000 15 years ago, and the guy I worked with, he was a lot more aggressive on salary. He kept jumping around companies. And when he left, it's about the same time I did, he was earning $95,000. As a instructor at community college, you make about base salary about $45,000. So I could be making about twice as much as that as a computer programmer. But I love education. So my wife's been very understanding about pay decreases going down. Okay. This talks about the int main void as part of every C program. Parentheses after the main indicate main is a program building block. I wouldn't worry about a lot of that for now. Every function. Good programming. Every function should be preceded by a comment describing the purpose of the function. That would imply that I put a comment here saying, this is my main function. Does that serve a purpose? No. Your documentation should only be meaningful. Why in the world would I even need documentation up here? You wouldn't. You know what this is doing. It's printing 2 lines. By the way, this indentation is important. When I slapped that down, I didn't do it on purpose, but I knew I needed to clean it up. I had one student one semester, and this was in it's either C or C++. And she's a good student in differential equations. A student, fantastic. Came in, she could not wrap her mind around programming because it's a different thought process. And part of her issue is she was all over the place with her indentation. She'd do this and she'd do this. Why in the world? So forth. And I told her, I said, if you don't decide upon some kind of consistent indentation, you're never going to be, get to master the programming because it throws you off. And she never did master it. She ended up dropping the class. But it doesn't matter what you pick, but you should have appropriate indentation. It should be consistent. When I look at a program, I should be able to see what that means. What code block is it in? This talks more about the escape sequences. The /n is the new line. The / itself is an escape character. They got a list of them here somewhere. Here they are. /n is a new line. That's the most common one you use. /t is a horizontal tab. So if you want to line it up so it looks good in columns, you use /t. /a is alert. I never use that. // puts a backslash in a string. /quote puts a quote in a string. And I can put these PowerPoints out here so you can access it because there's a lot of information. It's all in the book, but I'll put the PowerPoints out there too. So if I wanted to put a /a in here, let's see if that does the little bell. Huh. It's kind of pleasing on a Windows machine. It's not so pleasing on a Linux box. It's like meep, meep, it's like, what in the world is it beeping at?
Did your computer make the noise?
Yeah, I did.
I didn't hear it.
Oh, you didn't hear it? Yeah, it's almost like you received a message or something. I did it twice just to make sure I didn't receive a message in the background. Now, if I want to do the tabs, like I do sales /t, and then my next one is amount /t, and then date /n. The idea is that there's a space between them. They're columns. Sales will be in one column, amount will be in one column, date will be in one column. And so here I put sales. What in the world was sales supposed to represent? It's customer name maybe. So I'll say David /t. $10.31 for the amount. The date was March 3rd. /n. Now if I run that, I'm not very good with these tabs. I had to really play with them to get them. You see how this is lined up and this is good, but March isn't over far enough, is it? Oh, did I? Ah, that's why I didn't. Like I say, I'm not good at those. Should have killed that. There you go. Debug or build and run. Okay, there it's not. It's lined up pretty good, but that's what the /t is for. Makes it a little bit more user-friendly. Kind of hard to read, isn't it? But again, if you know what the /t does, then you can space it out. Let's see. Talk about some of those. Good programming. Add comment to the line containing a right brace that closes every function. I don't agree with that. Let's see. Printf. Mistyping. Okay, get down to here. Oh, indentation. Indent the entire body of each function one level of indentation. We recommend 3 spaces within the braces that define the body of the function. This indentation emphasizes the functional structure of programs, helps make programs easier to read. And I agree with that 100%. It doesn't have to be 3 spaces. It's whatever you decide, but you need to find some kind of structure so you can easily read it. You need to pick variable names, which we haven't talked about variables yet. You need to pick variable names that make sense, that are self-documenting. I've seen over and over at, well, I had one myself, a program I looked at Coke. The programmer had used all variable names with single letters, like A, B, C. Had no structure. Everything was like left aligned and so forth. And I went to my manager. I said, "There's no way I can figure out what in the world this is doing." I said, "I'll rewrite it." And to be honest, I don't remember what he had me do. I don't think I rewrote it. Maybe he gave it to somebody else because I was complaining too much. At IFR, that guy that left, and he deserved to be making 95,000. In case you're wondering, he was twice the programmer I was. Very excellent programmer. He could just do things that just would amaze you. And he was given a program to work on that another programmer had wrote. That programmer had used poor programming structure. And he said, I'm not going to do this. I said, I'll rewrite it. And he ended up rewriting it, and they let him do it. So again, the design of your program is what you really should focus on. I wrote my first program at Coke. I was so proud of it. I wrote it completely from scratch. I put my name at the top. And I said, written by David Hayes, the top programmer in the world, whatever I put in. So proud of that program. A year later, they called me in the middle of the night, 2 a.m., and my program had broke. And they said, "Hey, your program broke." And I said, "My program? Yeah, you wrote your name up top and so forth." I no longer put my name on any programs anymore. And your goal is, when you do write a program, you try to write it such that if you pick it up a year from now, 2 years from now, you can easily read it yourself because you don't remember what you wrote 2 years ago. So it kind of serves a dual purpose on your structure and your conventions. I'll never forget that, calling me in the middle of the night. Well, we knew exactly who to call. You put your name in it. So, okay, you can use multiple printfs, and I referenced that in that program. You can put however many you want. /n again is what goes to the next line. You can have them embedded. See how they have the /n embedded in here. Now here's another way to interact with the user. Printf, you print something to them so they can see it. Scanf is another useful function, and this allows us to get data. So that's what we're looking at with that. With a scanf, you can obtain 2 integers typed by a user at the keyboard, computes the sum of these values, and prints the result. You notice up here, there's still just the one include. But then down here, we have the scanf. So let's say I want to get 2 numbers from the user and add them together. Printf, program to add 2 numbers. /n. Printf. Input first number. /n. Now this scanf here, you got your scanf, and then you got this %d, which we'll talk about here in a minute, and then you got this the ampersand, integer 1. This integer 1 is referring to something called a variable. Variables, though it doesn't matter where you declare it, is usually declared at the top. So I declare it up here. All of you use this concept. I'm trying to think names. What's your name? Okay. How did he know his name?
Sure he's been told before by his parents.
Told before. And way back when, he stored it up in a brain cell, didn't he? So when I ask his name, he goes up here, retrieves it, and brings it back. A variable is just a brain cell of your program. So it keeps track of something. If I gave you a number, if I said 3 and 4, what numbers did I say?
3 and 4.
3 and 4. You took the 3 and 4, and somehow your brain stored them in brain cells, didn't it? That's what a variable is. It keeps track of information. So here, I can say int, and I can say num1 space or comma num2, and I could even have a third variable called the sum. Now int, remember up here I said int was an integer, a number with no decimal. So I start off with declaring it with int, saying these are going to be integers. And I'm going to have one declared num1, just like I gave you those two numbers, 3 and 4. You put 3 in one brain cell, you put 4 in another brain cell. I don't know how the brain works, but we'll assume I'm correct on that. I know nothing about medical, so I'm really probably way off on that. Then I do a comma, and I declare num2. And then I have another comma, and I call this the sum. Typically, you just use sum, but I got burnt one time real bad by using sum because it was a reserved word, which means I shouldn't have been using it. It conflicted with the program. It took me forever to find it. Now, these have been allocated, but nothing has been stored in them yet. So now, the scanf down here, you see down here, the first thing is it's got quotes, and then it's got a %d. And then comma, and then they got this symbol, num1, and then a semicolon at the end. See, they're just gone overkill with all these comments. Read an integer. That's what scanf does, is it reads something. So you don't need to comment that.
What does %d do?
This is the format of what it's looking for. Remember how I said the integer is in some programming languages referred to as decimal integer? That's what that D represents. It refers to decimal integer. So when you're reading an integer, you always use %d. Comma, and we're going to talk more about this, but this refers to how do we store data? You know, what does a ampersand mean here? We'll talk more about that. So then I say printf input second number /n scanf. I do another %d ampersand num2. I usually screw this up. I forget to put the ampersand there, and it won't store it in the proper memory location if you don't put it there. So that's why I was being really careful to look at this, so I didn't mess it up. Okay, now we want to add those two numbers together. So I'll say the sum is equal to num1 plus num2. Now think about how I do this in real life. I go up to, I can't remember the gal from Blackwell. What's your name? Brenda. I go up to Brenda. I said, okay, I'm going to add two numbers together. Now I'm looking at her real strange. And she's sitting there, okay, well, what do you want? Well, when I go up to her, I should say, okay, what's the first number? She tells me that the first number is 3. So I take the 3 and I store it off. In my case, I store it up in a brain cell or a variable. I then ask her, okay, what's the second number? She tells me the second number. I store it off in a brain cell, or in a program, you store it off in a variable. Then in my head, my brain's sitting there, okay, 3 plus 4 is 7, and I'm storing that in a separate location in my brain, a separate brain cell, or a separate variable. This is referred to as an assignment operator. This is not the same meaning as it is in algebra. This does not mean that you can move the num1 over here, num2 over here. What this does is it goes out here and gets the value of num1, it gets the value of num2, and plugs them in here and then adds them together. So it'd go grab 3, it'd go grab 4, it'd add them together. 3 plus 4 is 7, and then this assigns it to this variable over here. Now notice when I did this, I did not put the little ampersand here, did I? That's why I say it throws me, because you don't need it here, but you need it here. It's just how they got the scanf designed. And there's a reason later on. Okay, so I guess that's what we just did, add those two numbers together. Then we want to print it off. So we got our sum now. Printf. The F stands for formatting, print formatted. So we say the sum is %d/n, comma, and I don't think I need that little ampersand thing there, but let me check. No. Okay, so let's talk about what in the world this means. This is a string. Within the string, I have this specifier here, %d. What that means is I'm going to plug a decimal integer into that location. The decimal integer I'm going to plug in is the one I put over here. And so when this runs, this will take the value of the sum, it'll plug it right in here. Assuming I don't have an error in this. So let me run this. In case you're wondering why I keep doing that, I can't do F9 very easy. I have to push. Usually I shut off my recording when I do that. 3, 4, the sum is 7. Questions on that?
Scanf is your input statement, correct?
Correct. That's what gets the data from the user. Let's see, chapter 2. Hopefully I can remember what I assigned. Let's see. Write a program that asks the user to. I think that's when I assigned to enter two numbers obtained from the user printer: sum, product, difference, quotient, and remainder. We haven't talked about the remainder yet. Comparing integers, the largest and smallest. That includes the if statement, which we haven't talked about yet. Okay, let me just make up one then. Oh, this is one I assigned: the diameter, circumference, and area of a circle. So let me come up with a program. And area of a rectangle, I guess, since that's one formula I can think of real quickly. Integer. You think the sides will always be a nice number with no decimals? No. So there's something called a double. A double is a number with decimals. Now there's different types of doubles in terms of what kind of capacity it has, how big of a number it can store. But I'm going to read in the length. Now I could use L and W. Those would be perfectly valid variable names. But is this documented better? Yeah. There's no comments needed. I know what those are. Those are length and width. I don't have to think what L and W is. I'm going to calculate area. Maybe area is a good one to use. I'm going to, let's see, what else is there? Area perimeter. Let's make a spell. So again, using good variable names self-documents. I'm not big on comments if you write the program correctly. Okay, so now I need to say printf program to calculate area in perimeter /n, and let's say printf input length. You don't even have to put you could just leave that on the same line. Sometimes that's more appropriate. Scanf. %d is your decimal integer. And this is going to seem strange, because you think double would be %d, right? When we get down here, we're going to see it's percent, I believe f, if I remember it correct. Good programming. Yeah, I have no patience for that. %f. It'll tell me if it's wrong. And then I want to read in the length. Printf. I'm going to input the width. Scanf. %f. Width. Get rid of this now. My area is going to equal to length times width. How you specify multiplication in programming is with an asterisk. Your perimeter in algebra, you do like 2x, 2l. You cannot do that in programming. You have to use your asterisk. So you do 2 times length plus 2 times width. And now I need to print out the result. The area is %.2f /n area.
Why did you put %.2f?
Actually, I'll show that in a minute. The perimeter is %.2f /n perimeter. Make sure I deleted all that code down there, and let's see if I remembered this %f correct. I may not. Input length 3 point bunch of there 4 point like that. Didn't calculate something correctly. It didn't give me an error, but it says 0. Let's see what I did wrong. I bet this shouldn't be %f. Length width. Let's see, keep going down. Probably Google it and find it a lot faster.
Is the %.2f for the level of the amount of numbers behind the decimal point?
Right.
So maybe it didn't work because you overran.
Well, I didn't think I put that many in there. Let's see if I can remember. Let's see. C format specifiers scanf. Yeah, it says %F. That's not comforting. Geeks for geeks. Those are printfs. %D, %I, %I, %F, ampersand.
That has F for float.
Yeah, that's another name for a number with a decimal.
Because there's no space after the comma, between the comma and the ampersand.
Shouldn't matter. Printf. Let's see what length this says. %F/n length. Three. Okay, it's just screwed up right there, isn't it? How interesting. Let's go down here, see if there's any more. %D. I don't even see him using %F. C programming scanf floats. Stack Overflow is sometimes good, but it okay, that's Java. Ampersand? I don't see it. Of course, sometimes you're looking at you should just use %F as the first argument of scanf. Yeah, that's what I'm doing. Oh, but they're called float up here. Maybe that's it. Maybe you're right on that. Then what's the? Let's try that. Yep, that was it. So what's the format specifier for double? C format specifier for double. LF. So I should have used LF if I wanted to bring in double.
Because doubles are long floats, right?
Yeah, you can put bigger numbers in them basically. So, interesting. I won't remember that tomorrow, but okay. So now let's try it. 3, some big number there. 4. Now, and like you indicated, the reason why you put the .2 there is it rounds to 2 decimal places. So it's formatting. You can even put a number before the decimal here, such that if I put 20 here, notice how it has all these spaces here. It doesn't put leading zeros, just put spaces. So it's a formatting thing. When you have a float, a double, you can control it with this. Now, before it probably doesn't make as much sense, unless you just want to make sure it takes up a total of 20 spaces, with 2 of them being decimals. Usually you just see this in programs like %.2f and so forth. Is there any questions on what I did with that program? Do you notice what happened here? I got stuck, didn't I? Didn't do it on purpose. I really did get stuck. So what did I do? I used Google, right? I used resources. When you're as a computer programmer and you get stuck on something, you should go out there and use those resources. You should now you have to know certain keywords. I had to know that as a format specifier, right? If I didn't know it's called a format specifier, I could have probably Googled for 3 or 4 hours before I found the answer. I might be able to do a scanf and put a float in there and found something, or double. But having some of those names down really does help. Okay, so that's calculating area and perimeter. This program right here, the one I assigned out of the book, was to calculate the diameter, circumference, and area of a circle. So you had to modify the program I just gave you pretty much exactly with different formulas. Now there's coming up with the largest, smallest value, the average, and so forth. So let's talk a little bit more about some of the other calculations you can do.
Can I ask a question real
Sure.
quick? So in finding the area of a circle, do you just put in 3.14 for pi, or is there a special operator for pi because it's never-ending, non-terminating?
For now, you want to hard code 3.14159. We're going to see later on that there's a library for the math where you can bring in some of these. But for now, they just want you to hard code it. Is there any other questions on this? Now, I'm going to do the largest of 3 numbers. I don't think I assigned that. If I did, then it'll be an easy assignment. So I want to bring in 3 numbers. Float num1, num2, num3. Printf input first number. Scanf. How could I forget from 5 minutes ago? Is it %? Okay, the F is float. The double is LF, isn't it? Yeah, okay. Num1. Input second number. Scanf. Num2. You notice I'm typing this all over and over, aren't I? Edit copy and edit paste does exist in this. I would recommend, until you get comfortable with this, type everything. Don't ever use edit copy and edit paste. The more you type it, the more it'll seem in the syntax. Now, once you got that down, then you can do your edit copy all day long. Input third number. Scanf. %F. Num3. Up here, I got num1, num2, num3, but I want to calculate the largest number and smallest. I don't want to use max and min because those are probably reserved words, so I'll say the max and the min, just to make sure I'm covered. Drove my old manager crazy when I left. She edited worked on my programs, and I had the all over the place. Because you get burnt one time, and you don't want to be burnt again on that. Okay, what's your name? Scott. I got to come to Scott. I say, I'm going to give you 3 numbers, and I want you to tell me what the largest and smallest is. And I say, okay, 7. So to begin with, what's my largest and smallest? 7. So to begin with, we can assume the max is equal to our first number. And we can assume the min is equal to our second number. Or first number. Because they're both, when we just have one number, that's both our largest and smallest. Now, I want to check my second number. And think about how you do this. If I'm hungry, I'm going to go do something. That's a decision. If my money is greater than this, I'll go eat here. We can have an if statement. And we can say if num2 is greater than the max. What does that mean? Yeah, it's greater than num1, right? Which means it's now my largest number. So that means that the max is now equal to num2. Because, well, it's greater than the max, so it has to be our largest number now. I could check if num3 is greater than the max. If it is, now my largest number is what? Num3. You'd be shocked at all the different types of syntax people will write for determining the largest and smallest. It's very simple. You just check to see if it's greater than you set it like that. Now, I haven't done the min yet. So I'll say if num2 is less than the min, that now means my smallest number is what? Num2. So I'm going to say the min is equal to num2. And then I can say if, let's see, num3 is less than the min is now equal to num3. Now this is when you're writing your program, you're working on these, and you start struggling or anything, like you're not sure, you need to see more examples, email me. You can ask me to work any problem out of that section, and I'll turn on the recorder here, and I'll make a little YouTube video and send it to you. It's easy for me to do this. It's not so easy for me sometimes to look at people's code. Sometimes that takes me forever to figure out what in the world they've done and so forth. But writing a brand new program out of my own code, by the way, that is the easiest thing. When you're editing your own code, simple. Changing somebody else's code is a nightmare. So that's just kind of a general rule in programming. Okay, an if statement. An if statement is performed the same as in real life. Let's see, am I hungry? I don't know if I'm hungry or not. I haven't had dinner, but I did eat a late lunch because I was getting kind of weak. But if I'm hungry when I leave here, if I'm hungry, I'll go buy McDonald's on the way home. That's a true or false statement, isn't it? If I'm hungry, it's either true or it's false. That's what this is based upon. When you do an if, this is going to return true or false. This is a Boolean. This is a Boolean operator here. And there's greater than, there's less than, greater than or equal to, less than or equal to. We're going to see more of these. Equals equals is typically the equals. And exclamation equals is a not equals. Down here then, since I had one line of code, I could just put it underneath this if. If you have more than one line of code, we're going to see this. If you have more than one line of code, you have to put your braces like this. Because remember what I said earlier, braces imply that all this code is part of whatever function or if statement or while or for or whatever you're doing. By the way, it doesn't hurt to always put this here, even if you have one line of code, but it's not necessary. Okay, let's print off our result and see if it even works. Let's see. The max is, remember our format specifier. I can do a percent dot 2, or I can just simply do an F. This puts all the decimal places. There's nothing wrong with that. /n, and let's see, the max, printf, the min is %f /n, the min. So what this will do is when this prints, it'll grab the value of the max, it'll plug it in where the %f is. Now you can do this in one line. You don't have to have separate lines of code here. You can say the max is %f and the min is %f. Hopefully I'm not mixing this up with another programming language. They're not the only ones that use the format specifier. So where do you think the max will go? Assuming it works. Yeah, the first one. And the min, of course, will go in the second one. So you can do it in one line like this. Let's see if I just lied to you. Okay, so I'll put, see, I did do a %f, so I can put decimals. 3.1, 1.7, 8.2. The max is 8.2 and the min is 1.7. I didn't expect it to put all those zeros on the end. That's interesting.
So it will automatically parse between the first and second on the format identifiers. So you don't have to tell it like a %f A or %f B.
No, it just assumes the order. Like if I had a %D here or other, then it assumes that the second one's going to be my decimal integer. And this first one, which will go in this first %f. So it assumes the order of it is how it does it. Is that what you're asking?
Yeah, that's what I was asking.
Now I didn't expect it to round like that, so I don't like that, so let me put some .2s there. Now worse, I don't like it scrolling off the screen. I don't like to go back and forth. That's the worst thing programming, is have to scroll back and forth to see what in the world your code's doing. So I'd probably break this into 2 printfs just because I don't like that. Because realize you don't have to have a /n here. If you have it in 2 separate printfs, I can achieve the same line. Okay, 3.1, 1.7, 2.8. How strange. What did it do there? Max is 3.10. Oh, %f .2. I'm not dyslexic or anything. I don't know what I did there. By the way, this right here is the run, so you can do that very quickly. 1.7, 5.8. It didn't build though, did it?
You changed the code and then you didn't rebuild it.
So what's this one? This one's a build and run. Little cog in the there. Okay. And 1.72. Okay, that looks better. I'm getting used to code blocks myself. I wanted to do something different. Always before when I did this, I taught it using Visual Studio, and I never have taught using code blocks. So give me a chance to learn something new. questions on that? Clear as mud at this point. I got out of high school. I decided I wanted to go in forestry. I wanted to walk around the woods and have somebody pay me to do it. It turns out they don't pay you to just walk around woods. You have to work. And it was hard work, low wages, seasonal work. And I decided I didn't want to work hard for life. So I wanted to decide to go into computers. So I could sit on my butt and get paid good money. Went into computers. I took a couple programming classes up in Montana, dropped both of them. Actually, it took 3. I think I dropped all 3 of them. No, I passed the basic class, but there's an advanced basic, and I couldn't get through that. I was using Apple, and the person teaching it was IBM, didn't want to know Apple, which I can't blame them. So my skills were kind of poor. Went down, went to Fort Scott Community College, went to COBOL, where I just typed in programs out of the book. Do you think I'd learned programming then? No. I entered my junior year at Pittsburgh State not really having a good foundation programming-wise. And I was ready to change majors. That first programming class, nothing I wrote worked. I mean, 100% of them were wrong. And I went to the professor and I said, I think I'm a drop. Nothing I've turned in works. And he said, well, or no, I didn't tell him that. I said, I'm having a lot of trouble and I'm thinking about dropping. He encouraged me to stay in it. I don't think I told him that nothing worked. I ended up passing the class. Actually, I think he gave me an A. I suspect he probably never even looked at the programs, just put 100 on every one of them. But the reason I tell you this story is because if this is your first programming class, it is kind of rough. And I always tell people, if you're going into computer science, going into any kind of programming at all, you need to take as many programming classes as necessary. What does that mean? For one person, one programming class may be enough. They take it, they got these fundamentals down. Now, do I know all the syntax on this? No. I've looked some of it up in the PowerPoint. I've Googled some of it. But I know the basic programming constructs. And that's the part that you really need to feel comfortable with. You can look up the syntax anywhere, but you need to have those down. For some people, that may mean you need to take 2 classes. I had one person that I think he ended up taking 5 classes before he felt comfortable with that level. Realize that everybody's at the same place in your first programming class. It's like going through mud. It's just like this isn't making sense. It will. The more programs you write, the better you'll get. I guarantee it. The more you'll remember all the syntax, that you'll need a beginning parentheses here and a closing parentheses here. I tell you that to tell you not to get discouraged. To stick with it. Let me see if there's anything else. We only got 10 minutes left, and see if there's anything else. Let's see. Smallest, largest. I guess we already did smallest, largest, so you can probably for 3 numbers. But that's integers, which is a pretty slight change, right? You use int to declare the variable, and then you use %d for the formatting. Average. Okay, we looked at that one. Remainder. Let's talk about the remainder quickly. Okay, got num1, num2. Num1 is equal to 3.12. Num2 is equal to 5.13. Printf. The sum is %f/n. And then num1 plus num2. Printf. The quotient is num1 divided by num2. This is how you do division. Multiplication we looked at, we do an asterisk. Subtraction is obvious, you do a minus. Now the other one, I don't know if I remember exactly. It's modulus. So again, I could Google it real quick, which might be the easiest way. Let's see if they summarize it here at the end. Different books have different way of doing the modulus. Probably Google is faster. Okay. C modulus. Let's see. Percent. Okay, so printf modulus of 3 divided by 2 is, what if I think it's percent %d, so I think it returns a decimal integer. Num1, or not num1, 3% 2. Okay, let's see if that even works. Yep, that worked. Modulus, what in the world does that mean? 8 divided by 5. Think of old style division. How many times does 5 go into 8? 1 with the remainder of what? 3. The modulus is the remainder. So that's what they're talking about when they say the remainder or the modulus. So if I came up here and I put 8 divided by 5, and put 8 here, 5, then that should return 3. Try to get used to that button. See how it returns 3? That becomes important in mathematical applications because then you can tell if something's even. Because if something's even is when you divide by 2 and your remainder is 0. It's odd if your remainder is 1 if you divide by 2. So those are used in mathematical applications. I don't know if anybody's a math major, but if you were, then if you were going to program that, then that's how you do it. Where in the world is it? Okay. Sum, product, difference, quotient, and remainder. Again, the modulus is how you do the remainder. This is probably different in many programming languages. Some will use a percent. I've seen some use 2%. Some use a mod statement. So it's kind of all over the place on that. I think there's even one programming language where you use the other slash. Like that. So I think everybody has a different viewpoint. Now I'm going to go ahead and stop the recording there.